Hello, Dan Nedelkowski here from howtomechatronics.com. In this tutorial we will learn what is Schmitt Trigger and how it works. The Schmitt Trigger is a logic input type that provides hysteresis or two different threshold voltage levels for rising and falling edge. This is useful because it can avoid the errors when we have a noisy input signals from which we want to get square wave signals. So for example, if we have a noisy input signal like this that is meant to have two pulses, a device that has only one set point or threshold could get incorrect input and it could register more than two pulses as shown in this illustration. And if we use the Schmitt trigger for the same input signal, we will get a correct input of two pulses because of the two different thresholds. So that's the primal function of the Schmitt trigger, to convert noisy square waves, sine waves or slow edges inputs into clean square waves. There are many logic ICs that have built-in Schmitt triggers on their inputs, but also it can be built using transistors or easier using an operational amplifier or comparator and just adding some resistors to it and a positive feedback. Here we have an op-amp which inverting input is connected to the ground or 0 volts and the non-inverting input is connected to a voltage input V-in. So this is actually a comparator that compares the non-inverting input to the inverting input, or in this case the input voltage V-in to the ground or the 0 volts. So when the V-in value is below 0 volts, the output of the comparator will be negative VCC, and if the input voltage is above 0 volts, the output will be positive VCC. Now if we add a positive feedback by connecting the output voltage to the non-inverting input with a resistor between them and another resistor between the V-in and the non-inverting input, we will get the Schmitt trigger. Now the output will switch from VCC minus to VCC plus when the voltage at the A node will cross the 0 volts. That means that now by adjusting the values of the resistors, we can set at that value of the V-in input the switch will occur using the following equation. We get this equation with the following relationships. The current I through this line equals V-in minus VA divided by R1, as well as VA minus Vout divided by R2. So if we replace the VA with 0, as we need that value for the switch to occur, we will get the final equation. For example, if the output is minus 12 volts and the V-in input is negative and rises, the switch from minus 12 volts to plus 12 volts will occur at 6 volts according to the equation and the values of the resistors, and vice versa. When the V-in input is high and declines, the switch from plus 12 volts to minus 12 volts will occur at minus 6 volts. In order to get two different non-symmetrical thresholds, we can use this circuit of an inverting single powered Schmitt trigger. Here the Vref voltage is the same as the VCC of the op-amp. Now, because the V-in input is connected to the inverting input of the op-amp, when its value will reach the upper threshold, the output will switch off to 0 volts, and when its value will decline to the lower threshold, the output will switch on to 5 volts. Here's an example of how we can calculate the thresholds. The Vref and the VCC will be 5 volts and the 3 resistors will be the same, 10k ohms. So what we need to calculate now is the voltage at the A node. In the first case, when the output is 0 volts, our circuit will look like this, a simple voltage divider, and the value of the VA will be 1.66 volts. This means that the Vin input needs to decline below that value in order the output to switch on to 5 volts. Now with these 5 volts at the output, the circuit will look like this. The value of the VA will be 3.33 volts. This means that the Vin input needs to rise above that value in order the output to switch off to 0 volts. We can also build a Schmitt trigger using transistors. You can learn how the transistor Schmitt trigger works in my next tutorial. Click here to visit it on my official website. Thanks for watching, and for more tutorials visit my official website howtomechatronics.com.